I'm Anil Kumar. Here is a brief introduction to sequences. We are going to talk about some basic concepts connecting functions, sequences, and terms. As you know, sequences are discrete numbers. We could have finite or infinite discrete number sequences. These sequences can be represented by general term or explicit formula, or they could be represented by recursive terms or recursive formula. We'll also provide you with some examples to explain the concept. Let me take a set of odd numbers to begin with, right? Let's take odd numbers. Odd numbers are numbers like 1, 3, 5, 7, 9, 11, and so on, right? Now these are all discrete numbers. They have a pattern. You could describe these numbers in many different ways. We could write this as a function. We can say the function f of x representing these numbers could be 2x minus 1, where x belongs to natural numbers, right? We could also write these odd numbers, since they are numbers and they are natural numbers. Instead of writing with x, we could replace x with n. So we get to the formula f of n equals to 2n minus 1, where n belongs to set of natural numbers, right? Now n set of natural numbers is what? Let me write down here, where n is the numbers 1, 2, 3, 4, and so on, right? Natural numbers do not include 0. That's very clear. The idea here is that when we talk about sequences, we are dealing with only natural numbers, and therefore it's a good idea to write in general f of n instead of f of x. So that is a minor change in our function notation. We also prefer to write this sequence as Tn equals to 2n minus 1, where n belongs to natural numbers. Now when I write Tn, then I'm actually describing my sequence in terms of term numbers, right? So Tn, where Tn is the general term number. Now, what are term numbers? Well, all these numbers in our sequence are actually given their position, right? So they are defined by position. So this is like term number 1. We say this is T1. This is T2, term number 2. This will be T3. This will be T4, and so on. In general, we can write Tn, where Tn means nth term. You get an idea, right? So the first term is T1, right? And second will be T2, and so on. So a general term will be Tn, where n is any natural numbers. So that is the basic understanding of the term number, right? So in a way, what we have seen here is that any function which outputs numbers could be treated as a sequence. Since we are dealing with only natural numbers, we prefer to write in terms of n, where n belongs to natural numbers, and T of n is a simpler nomenclature or the format or the method of writing a general term. Now at times we also describe our sequences in terms of recursive terms. Like this particular sequence, we could say start at 1 and then add 2 each time. Right? So we have been saying odd numbers could be written as start at 1, add 2 each time. Now this could be written as, let t1, the first term, be 1, and then tn equals to previous term, which is tn minus 1 plus 2. Now if I write in this form, then it is called recursive formula. Where I am giving you the first term and rest of the terms are described as some operation on the first term. So you keep on doing the same operation to get rest of the terms. Right? So I hope these things are linked and well understood. We'll actually talk about them in more details in this video. Now as far as finite and infinite sequences are concerned, if I just write odd numbers as 1, 3, 5, 7, 11, so on, it could go up to infinity. So this series will be infinite series. Let me write sequence. However, if I write a sequence which is, let's say, even numbers 2, 4, 6, 8, 10, 12. So here we have finite number of numbers 1, 2, 3, 4, 5, 6. So here in this we have finite sequence where we have only 6 terms with 6 terms. Right? So that is how finite and infinite is connected. Right? Now let's take a few examples and try to understand it in further details. So as a part of question number 1, we'll actually determine first 3 terms of the following sequences. Now I've given these sequences in general terms, right? You could also call them as general formula. The first one is f of n equals to 2n plus 1, and b is tn equals to 2 to the power of n plus 1 divided by n plus 1. We have to write the first 3 terms. Now, in general, it is understood that in both n belongs to set of natural numbers, right? So let me write it down clearly now. N belongs to set of natural numbers. It is by default understood, so it may not be mentioned in your question, right? So first 3 terms means first term will be for n equals to 1. So if I write n equals to 1, I get f of 1 as equals to 2 times 1 plus 1, which is 2 plus 1 equals to 3. So that becomes the first term. For n equals to 2, we can calculate f of 2, which will be 2 times 2 plus 1, which is 4 plus 1, and that gives us 5. And the third term will be when n is 3, and we can write this as f of 3 equals 2 times 3 plus 1, that is 6 plus 1 as 7, right? So our sequence, in our sequence, first 3 terms will be 3, 5, and 7, correct? Now I would like you to write down the first 3 terms of the given sequence, part B. So what you have to do basically is you have to substitute n equals to 1, get the first term. So n equals to 1 will give us t1 as 2 to the power of 1 plus 1 divided by 1 plus 1. That is 3 over 2. So 3 over 2 is our first term. For n equals to 2, we get the second term t2 as 2 square plus 1 over 2 plus 1. N is replaced by 2. Clear? 2 square is 4, 4 plus 1 is 5, and 2 plus 1 is 3. So we get 5 over 3 as the second term. Now if n equals to 3, then we get the third term, t3, which will be 2 to the power of 3, which is 2 cubed, 8, right? Plus 1 divided by 3 plus 1. Now 8 plus 1 is 9, and 3 plus 1 is 4. So we get three terms as 3 over 2, 5 over 3, and 9 over 4. So I'd like you to pause the video, look into this solution and understand the basic concept. So when we say first three terms, you have to substitute n as 1, 2, and 3 in the given formula to get all the terms, right? Now let's move on and take up question number 2. You can pause the video, answer this question, and then look into my suggestions. Question number 2. Determine first three terms of the following sequence. We are given t1 equals to 1 and tn is 2 times tn minus 1 plus 1. Part B is t1 is 1 and tn is square of tn minus 1 plus 1. Now this type of formula is called recursive formula, right? Or recursion formula. We are defining previous terms. We are defining a term in terms of previous terms, right? So we are including previous term. Which is previous term is n minus 1. You see that part, right? So whenever you see something of this form, it becomes a recursive formula. Now let's try to build this sequence. We are given t1 is 1, so let's write t1 equals to 1. Now tn, so for 1 we are given a value. If n equals to 2, that is t2 will be equals to 2 times tn minus 1, that is to say 2 minus 1 plus 1. Now what is 2 minus 1? 2 times 2 minus 1 is 1 plus 1. So that means twice the first term and then you add 1. You get an idea, right? So it is twice the first term, which is 1, and then you add 1. That gives you the value 2 plus 1 as 3. Clear? So that is how we get our terms. Now let's look into the third term. T3 equals to twice t of n minus 1. N is 3. So it will be 3 minus 1 plus 1. That is to say, twice 3 minus 1 is 2 plus 1. Now, twice the second term, so it is twice the second term, which is 3, and then we'll add 1, right? So that gives you 6 plus 1, which is 7. So the three terms from the given formula will be 1, the number 3, and then 7. Perfect. So that is how you have to build your sequences in terms of the previous term. So I hope how to apply recursive formula is clear, right? Let's do it once again for part B. We are given t1 as 1. So t2 will be, replace n with 2. t2 minus 1 whole square plus 1. Now 2 minus 1 is 1. So we have to square the term, first term, and then add 1, correct? Squaring 1 means 1. So we have 1 square plus 1. That gives you 1 plus 1 as 2. So that is the second term. Third term will be substitute 3 for n. So we get t 3 minus 1 whole square plus 1. That is to say, square of second term and then you add 1. Now second term is 2. So we'll square 2 this time and then add 1, which is 4 plus 1 or 5. So the sequence which we get is 1 and then we get 2 and then we get 5. So these are the three terms as per the recursion formula given to us, right? Now let's take more examples. Here is question number 3. Write explicit and recursive formula for each sequence. This time we are given the sequence. We are given 5 terms and we have to write both. Explicit means general formula and recursion means in terms of previous term. So the first term is 3, then we add 5, right? And then the first term is 3, we add 2 to get 5. So it is like adding 2 each time. It's a sequence which is generated by multiplying 2. Now we could write this as, let me write recursive formula first, right? So we can say T1, the first term here is 3, right? And we are getting the other terms by adding 2. So we can say Tn is previous term, which is Tn minus 1 plus 2. So that becomes our recursive formula. Right? So recursive formula will include both the things. The first term, which is 3, and then what we do on that term to get the next term. So this is our recursive formula. Now, let's try to give a general formula that is also called explicit formula, that we want to write what is Tn equals to. So we have to write it straight. What is Tn equals to, right? First term is 3. So we could write this as 2n plus 1, right? Is going up by 1. First term is 3. So we could write this as 2n plus 1, where n belongs to set of natural numbers, right? So in all our cases, n belongs to set of natural number is kind of common, right? So when I write this as Tn equals to 2n plus 1, where n belongs to general natural numbers, it becomes explicit formula. Now clearly, explicit formula has an advantage. If I want to find 100th term, we can directly figure it out, right? So that is the major advantage. Okay, now I'd like you to write down both the formulas for the next sequence, which is 3, 6, 9, 12, 15. Now let's write recursive formula first. We know the first term is 3. Next term, how do we get? By times by 3 or adding 3, right? So we can say if we do add 3 also gives us the same thing, right? So we can say it is Tn minus 1 plus 3. So you can add 3 to previous term to get the next term, and in this particular case n belongs to natural numbers, right? So that becomes our recursive formula for the given sequence. Now a general formula could be written as the first term is 3, second is 2 times 3, then we have 3 times 3. So we could write Tn in general as 3 times n, right? So we could write this as 3n. It's multiples of 3. So that becomes the general formula. And in both cases, we know n belongs to natural numbers. Correct? So I hope this concept is clear. Let's have a few more examples to practice. Question number 4. You need to write explicit and recursive formulas for each sequence. Now, to begin with, let me write down in general that n belongs to natural number is for all our sequences, right? Now, to write explicit formula, we have to directly write a formula which could give us the term, nth term, right? What you notice is it is ones where the sign is changing. The second term here is negative, right? First term is positive. That is to say, I can say Tn is equal to minus 1 to the power of, since I want to make the second term negative, I can write this as n plus 1, right? N plus 1. So if n is 2, 2 plus 1 becomes 3, and every odd power of negative will be negative, right? A general formula. This is also called the general formula, right? Explicit or general formula. Okay. Now let us write down the recursive formula. For recursive formula, we have to define the first term. T1 is 1. And what is Tn? To the previous term, you just multiply by minus 1, right? So you can say it is negative of Tn minus 1. So that works, right? And in all our cases, we are taking n as set of natural numbers, right? Now let's take up the next example, which is alternately negative as we had in this case, but the numbers are 1, 2, 4, 8, 16, and so on. Now in this case, what could be the formula? Well, here we are going by powers of 2. So a general term, Tn, could be written as 2 to the power of, now how do you get 1? 2 to the power of 0 is 1. However, in our set of natural numbers, we do not have 0. So we should begin with 1, that is n minus 1 will make the first term as 0 in the exponent, right? Is that clear? And since it is alternately negative, it is minus 2 to the power of n minus 1, which is going to give you the given sequence. So that becomes your general formula. Correct? So that is how you're going to get this general formula. Now to get the recursive formula, we can say T1 is 1 and Tn is negative 2 times Tn minus 1, because you're multiplying by negative 2 to get the next term. Perfect. So that is how you could get the recursive formula. So I hope it is absolutely clear, right? Let's move on. Few more examples. Here is a very interesting example. We need to write explicit and recursive formula for the following. I'd like you to pause the video and answer this question. Well, you could write 3 as 3 over 1. And then I think it'll make sense. So what are you doing in this particular sequence? You will observe that you're multiplying by 1 over 10, right? 10,000. So basically, when you move from one place to the other, you are only multiplying by 1 over 10. So you could write general formula as, or the explicit formula as Tn equals to 3 is constant on the top, right? So 3 over 10 to the power of what? Now in the first term, it is 10 to the power of 0, and here is 10 to the power of 1. So it has to be n minus 1, correct? So that becomes the explicit formula where n belongs to set of natural numbers. And the recursive formula will be, we have to write the first term, which is for us 3, and nth term will be, you have to multiply 1/10, 1 by 10 of Tn minus 1, correct? So that is how you get your recursive formula for the given case. You need to write explicit formula for the given sequence, which is 2, 3 over 4, 4 over 9, 5 over 16, 6 over 25, 7 over 36, and so on. Let us rewrite. So we have the first term as 2, then we have 3 over 4, 4 over 9, 5 over 16, 6 over 25, 7 over 36. You can see this is our term number 1, this is term number 2, 3, 4, 5, 6. So that is the term number, right? So if you see the numerator, it is one more than the term number. We have to give general formula or explicit formula. So we can write Tn equals to n plus 1 in the numerator, right? So because every term is one higher than the term number, as far as denominator is concerned, we could treat this as 2 over 1. So these are squares of natural numbers. 1, 2, 3 square. Fourth term is 4 square. So I could write this as n square, where n belongs to set of natural numbers. Correct? So that is how you could actually write this particular sequence. So I hope it is simple, right? Here is question number 7. You need to write recursive term for the given sequence. Let me rewrite. 1, 1, 2, 3, 5, 8, 13, and so on. I would like you to pause the video, take this as a test question, and then write down your recursive formula for the given sequence. Now this is a very special sequence where we are involving previous two terms. Now that's a hint for you. So you can now write down the formula. Well, what you notice here is that the third term is sum of previous two. So here we are looking for next term is sum of previous two terms. So in this particular case, we'll define T1 equals to 1, T2 is also 1, and we can say that Tn is equal to Tn minus 1 plus Tn minus 2, where n has to be greater than 3, right? We know two terms, n is greater than 3. Do you see that? So we get the third term, fourth term, and so on as sum of previous two terms. So that is how this interesting series can be written as a recursive formula, right? So recursive formula will include all three. And as you know, n for us belongs to set of natural numbers, right? So I hope with this you have clear idea of what sequences are. These are discrete numbers which could be represented with a formula or a general term. Each general term could be written as an explicit formula or as recursive formula. I hope these 7 examples help you to understand the topic. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.